Hello, everyone. I'm Nick White. I'm with Ergon, and we are a refiner based in the United States, making paraffinic and naphthenic chemistries and solutions for the rubber industry and a number of other process oil industries. And we're actually also very, very involved with sustainable chemistries and renewable chemistries as well. But my colleague, Dr. Christina Bregman, yesterday talked about a lot of the solutions that we have for renewable and sustainable oils for the rubber industry. But what I'm going to talk about today is really mineral oil options globally. There is an evolution going on in the refining industry separate of all of the exciting changes that are happening in the rubber industry as well. So just going to kind of talk about that, how it affects the chemistries regionally that are available to you, and what we can kind of expect in the future. So there we go. All right. So just to start out, I like to talk a lot about rubber process oils. It's very important to all of us. We use it every day. But in the big picture of the aggregate of all the refining capability in the whole world, how do our products kind of fit in? And what you can see is this is a barrel of crude that comes out of the ground. And that's 42 gallons. And of that barrel of crude, what comes out of that we use? Well, what you can see is the vast majority of what comes out is combustibles: gasoline, heating oil, jet fuel, refinery gases, residual fuel oils. 95% of the refineries in existence today are in the business of making combustibles to power our cars, to heat our homes, to make petrochemicals. This is us right here. A little less than 1% comes out as what we would describe as a lubricant oil. And then if you take this 1% or this 0.9% and you break that down over here, what you will see is the vast majority of that 1% goes towards lubrication. Engine oils, industrial oils, metalworking fluids, greases. Really, we fit right here in this 8%. That we would call in the refining industry process oils. And then if you break that 8% down even more, you'll find that rubber process oils makes up probably about 40% of that pie right there of 8%. So if we right here in rubber process oils are 40% of 8% of 1% of all the refining capability in the world, it makes a lot of sense as to how the refining and the rubber process oil business has evolved. So today, over half of all the rubber process oils made are actually made by specialty refineries that are focused on providing lubricant oils and process oils for those companies and customers that really need it. You used to be able to buy a lot of rubber process oils from Shell and BP and Exxon, and those days are really over. The process oil market has almost become too small for them. They're focused much more on other industries. So, talking a little bit about like the big major oil companies of the world and the specialty oil companies, what you'll find is just a difference in what they produce, right? So a typical oil refinery, just if you take all the refineries around the world, what do they make? Again, this is kind of similar to what I showed a few slides back, right? 86% are combustible fuels, and then we're right here with base oils that get turned later into process oils. For us, Ergon, and a number of other companies around the world that focus on the rubber process oils, what you'll find is that, we're making, like just us, Ergon, we're making 60% of what comes out of our refinery are base oils. So we would sell those into the lubricant industry and also into the process oil industry and the rubber process oil industry. So we're only making, 19-20% combustible products simply because we have to make these products. So now that we've kind of talked about what's made, how much is made, how we fit into it, we can kind of talk about what types of refineries in the world of the people that make rubber process oils, what type of refineries make these oils that we use, and what are the different chemistries. So what you'll find is that if you start with crude type, there are two different types of crude in the ground, roughly. Okay, there is more paraffinic crude and more naphthenic crude. Paraffinic crude tends to be a more saturated product, whereas naphthenic crudes tend to have more unsaturation in them. So you take these crudes and then you have different ways to process them. This is just three. There are more than three, but these are the kind of the main three for the rubber process oil industry. So a big one is a group 1 extraction. So this is a solvent extraction process. You use a solvent, you clean up the oil, and what you get out of that is you get paraffinic oils that are cleaned up from the paraffinic crude. You get bright stock, which is a product that's in high demand in more saturated rubber applications. And then you get what we call aromatic oils, right? DAE was one of the big ones that was used for years, and it's carcinogenic and it's been banned. So what these guys did is they started making TDAE, RAE, MES. These are non-carcinogenic, low PAH oils that the rubber industry can use. If you go down to the kind of next step, you have a Group 2 hydrocracking technology. So this is a newer technology than Group 1, and instead of extracting extracts, right? So DAE, TDAE, RAE, MES, these are all used by the highly polar tire industry applications. But in the Group 2 hydrocracking process, none of these extracts are produced. With heat, temperature, catalyst, and a lot of hydrogen, they literally crack the molecules, reform them into straight chain or isoparaffins, and there's no extracts that come out of it. And the reason I differentiate between these two is because the Group 2 hydrocracking is the new preferred technology. Actually, refiners are starting to evolve even further to Group 3 products that are even more saturated. So keep that in mind when we look at the next slide. And then in the end, we have naphthenic, and naphthenic is a different type of crude. It's a more unsaturated crude that comes out of the ground, and it's going to make products that tend to provide better solvency than some of the paraffinic oils, and that's a hydrotreating process to make those. So what we see when we talk about Group 1, Group 2, this is Group 3 that I mentioned briefly, and the naphthenic oils, what you see is the trend here in the global output of these products. So again, what you're finding is that these Group 2 and Group 3 oils that are highly, highly saturated, they are being made more and more because this is what the motor industry, the motor oil industry and lubricant industry prefers, right? If you go back real quick to this slide again, you see this is what's being demanded of this 1%, and the vast majority of it is lubricating applications. So they're who drive really the molecules that are made. Process oils and rubber process oils are only at about 8%. So this is the trend that you see. So what you're seeing is how does this affect the type of applications we use in rubber? A lot of times you pair oil and rubber due to polarity and compatibility. And what you have is, kind of your more polar applications and your more non-polar applications. So what you see is that back in 2004, there was tons of product that fit very well into polar rubber applications, SBR, BR, tire rubber, those types of things, and not so much for the more non-polar rubbers like EPDM, butyl, those types of rubbers. And what you see is that trend is changing, right? So this just kind of shows what we're in that trend, what we're losing as far as the oil and as far as the properties of the oil, right? So in Group 1, you get both low and high viscosity, and you get solvency in your oils, right? In Group 2 and Group 3, you start to lose that solvency because it's a highly saturated molecule. Aniline points go way up, and solvency and the ability to help with cross-linking and functionality kind of goes down. And you also start to really lose viscosity when you get into these other products. Naphthenics, provide the same things as Group 1s for the most part, but there's no wax that comes out of naphthenic production. So, kind of to wrap everything up, this is kind of what it translates into as far as the polarity of different polymer systems and the oils that are made today, right? So what you have is these more non-polar rubbers that are being well served by mineral white oil or medical white oil, technical white oil, Group 2s, and a lot of your recycled oils that are made today are highly, highly saturated just because that's how they're processed. You take the dirty used motor oil, and to clean it up, you end up having to saturate it quite a bit to clean the molecule up. You've got the Group 1 paraffinic oils right here, which have been really a workhorse. They've been used quite a bit in the rubber industry, particularly in Asia for many, many years. But those are starting to, the production of those are starting to go away. Naphthenic oils and black oils, which are a type of naphthenic oil, these are specialty products. If you go back to the previous slide, it stated about 9% of total production for a very long time. It's a niche. It's there. People use the chemistry. Not too many changes. And then you have your REE and TDAE oils and your DAE oils, again, that are in blue. They're linked to the Group 1 paraffinic. And then you have all of these things happening. Group 1 starting to slowly go away. Group 2 starting to grow. And then at the same time, we're all looking for recycled, renewable, sustainable oils, right? So what you start to see is a lot of people go into like recycled oils or pyrolysis oils, and also quite a bit to plant-based oils. And your plant-based oils are highly, highly polar in nature. So they kind of fit down here as far as compatibility with your different rubber systems. So the last slide is just to kind of give another picture. This is the rate of decrease or increase in Group 1 refining production around the world. So again, what you start to see, these refineries that are making Group 1 base oils or are making TDAE, REE, MES, you start to see that they're starting to go away. And again, this is because the refining industry is moving more towards what the lubricant industry wants, which is highly, highly saturated products. So we start to lose solvency and viscosity that we need in some of our applications. We're starting to lose that around the world. China is the only place where there's actually been a growth in Group 1 production. This is not necessarily a bad thing. It's just the point of this presentation is really to show that you have to think strategically about how you source your raw materials, and the rubber process oil industry has been remained kind of static for a really long time. But we're starting to see some changes to where your availability of some of these oils and chemistries will start to change over time. There's been tons of rationalization in the Americas and in Europe. There's still quite a bit of Group 1 availability throughout Asia, but that is slowly starting to change. So that's my presentation. Any questions? No? Oh, yes.
Yeah. No problem.
One question regarding in the previous slide, the bottom part, that's one. That's the RBD and the revitalized plant-based oils. You are describing here a wide range of compatibility. Are them in general principle compatible with all the range you reported here, or there are different types of RBD and derivative plants that are more specific for this segment?
Yeah, so when you start to get into plant-based oils, I have right here that they're compatible with these oils, but these are not drop-in products at all for, like, let's say a TDAE or an RAE. These oils are insanely polar, so you have to really change your formulation to incorporate these oils. Now, among these oils, are there any that are more or less compatible with BR, SBR, NBR? Typically, when you have a plant-based oil, it's a triglyceride, and so you have a glycerin backbone, and you've got three fatty acids, right? And there is saturation differences inside those fatty acids that can make a difference. Something like a soybean oil has quite a bit of double bonds. Something like a palm oil is pretty saturated when it comes to those fatty acids, but you've still got an ester group that sits on top that provides a ton of polarity. So it's kind of a different structure oil. No matter whether you use a more or less saturated vegetable oil, you're going to have a lot of polarity in it. So what I'm finding in what we sell to our customers of vegetable oils, it really comes down to what's locally available and what's the cheapest. And they try to make that work because they're having to do quite a bit of reformulation anyways to get the product to stay in the rubber.